Everybody here? Everybody who should be here probably is here. I don't know if someone should introduce me or whatever. So I'll introduce myself. So my name is Maciej Próchniak. I work in Talk. We are a software house based in Warsaw. And today we'll be talking about zero-coding systems. Okay, so I hope you enjoyed the conference. It's really great. We are the kind of alley. The swags are great. The conference center is beautiful. But I have kind of bad news for you because they want to get rid of you and me. And who? Well, the business people, the analysts. Because think about it. They pay us so much. They have to send us to these beautiful conferences. And we are just cost generators, right? They are the kind of profit center, and we are the liability. We're not the assets. And they think, okay, we know the business rules. The analysts even know SQL. So why do we need those expensive coders to transfer these ideas, to pay them so much, and so on? So, of course, we know that this is not true, and they cannot deliver this beautiful crafted with love Scala code that is tested and so on and so forth. But maybe, let's look at this case. Do you know what it is? This is Scratch, right? This is a tool for web-based kind of block programming, and my 9-year-old son can grasp the arcades of that, and people do really crazy stuff with that. They can even build some kind of arcade games. If you Google it up, you can find many beautiful examples. So if my 9-year-old kid can use Scratch, then maybe business people also can do this. I mean, most of your business logic probably isn't complex enough not to be possible to express in this nice tool. And if it is, there's a better tool. This is the most powerful and complex business application that ever existed, right? This is Excel sheet or Google Docs. There are so many ways that companies can use them. Sometimes I think even the whole companies run on Excel, like for human resources, accounting, time tracking. Even us at Talk, we use Google Docs in so many different ways. In fact, you can think about it. If you think about it long enough, you can even do event sourcing and stuff like that in Excel. I can tell you something about this. And do you know what this is? These are real business requirements for one of our most complex projects, right? So this is how business people communicate with us. Now, when you look at it, probably you can understand that this is code. This is not only code. It's already obfuscated, right? I have no problem to put it on the slide, and you will never guess what it does. So the business comes with these requirements, and our best people will probably spend around 2 weeks trying to figure out how to transfer it from this Excel to Java classes, right? To our domain. So maybe these business people are right. Maybe they can just run Excel in production and everything will be fine. Of course, we're still needed, don't worry. Or just worry just a little bit. So what this talk will be about? This talk will be about enabling business users, or analysts for that matter, kind of semi-technical people probably, to change the business rules of our application, when it works, when it doesn't. We won't tackle the problem of user interfaces, although I know there are a lot of beautiful tools that let business users kind of believe they can handcraft UIs, but I have no idea about them. And I also want you to remember my perspective. I work for a software house, so our way of work is that we are at the Talk, and there are other, of course, vastly inferior vendors. And these are our clients, right? Probably these are some kind of large enterprises like banks, mobile operators, and so on. So they have also many teams, and there are certain boundaries between the teams that are our clients, and the boundaries between us and them. And this is the biggest boundary, right? Because no matter how good relationships we have with our clients, and we do have pretty good relationships, there's this chasm, right? We're one company, we want to make money on them, and they are the other company. They don't want to pay us money. So this is the point when they really want to configure as many things as possible by themselves, because they don't have to ask us for help. Okay? So the agenda is that we start with some simple stuff like configuration, DSLs, some basic widgets. Then we move to more complex stuff like Drools, BPMN. and then I'll tell you about just a little bit about my current project that we use some lessons learned in the past. So let's start with configuration, right? Let's imagine a system like that, right? We have like a large company like bank, retail, or mobile operator, and they have this notification system, right? Everybody wants to do omni-channel stuff right now, so they want to have some consistent messaging through SMSs, mails, push notifications to mobile applications, and so on. So they build these notification systems, and they want to configure how the messages are passed. And we build that. It's a really generic system. You can configure everything in that database, right? So their analysts can do it. And everybody seems to be happy, right? So they don't need development for that. But then I overheard at the kind of email conversation something like this. Piotrek, this is the guy from our side. Don't make changes to configuration on production until we review them and test them. So he says, okay, but you designed the system so that is so configurable so that I don't need to ask you to do the changes. And now you ask me to do the changes and then let you review them. So what's the point of me being able to configure it? And the reason is that even the configuration database or property files can be complex enough so that the business people and analysts are not able to use them, or they are not confident enough to deploy them on production, right? So not to mention coding or widgets or whatever. So let's move to some kind of more successful case. This time we'll talk about logistic operators. So they deliver parcels, they have warehouses and so on, and they have many suppliers, many vendors. They want to kind of communicate with them, probably using some ancient protocols like FTP, mail, web services over mail, or stuff like that. And again, we were to deliver some kind of integration solution for them, but these partners come and go, and they don't want us developers to code each time something changes with their vendor or partner. So we figured out we can teach them how to use Apache Camel. This is a nice integration framework that you've probably heard of, and it doesn't need coding. You can do this nice XML DSL and configure some routing, right? Take, for example, stuff from one database based on some XPath expression, send it to one file or another. And for more simple integrations, it's enough for them, right? So they are not developers, they don't have IDEs, they don't have Maven. They just write this in some kind of XML editor, this piece of stuff, and then deploy it by just sending the files somewhere. And then we've learned that for more complex integrations, to document them, they use this tool called Altova MapForce. This is pretty, I would say, maybe ancient tool, but it worked for them. And we figured out that this tool can generate something they called code. We call it crap, but it's auto-generated, so you don't have to look at it. And we can quite easily integrate it with our integration solution. So they can use this to code many integrations. And they can easily come up with this. I hope you can spot that here there's a bug. Okay? It was not so easy for us to spot, but okay. So they are doing this, and they are kind of happy with that. And we are also happy because we don't have to look at this. Okay, so the lessons I learned is that it's good to know what your users, business or analysts, use and try to integrate their existing solutions to your system. And it is very important to make them easy to deploy stuff, right? Because they can only just make some file, run some script, and voila. They don't want to install Maven, IDEs, and so on, right? Let's move to something just a little bit more, I would say, elaborate, and this is the DSLs. This time we will move to another system, this time for mobile operators. So, as you probably know, they have lots of different kind of tools and devices, base transmitter stations, switches, routers, and so on and so on. And from time to time, they crash. Or, for example, this thunderstorm, probably we'll have one in a few hours. And then, if the thunder strikes some base transmitter stations, strange things may happen, right? So they gather all the alarm signals, SNTP traps, and so on. They want to aggregate them, process them more or less automatically, and generate some alarms for their kind of technical team and so on, like SMSs, stuff like that. And also they want to be able to easily, for example, ignore some alarms, to aggregate them, and so on. And the thing is that the rules change pretty quickly, right? Because, for example, there may be some planned work when some guys just go to some base transmitter station, they will turn it off, they will break some cables and so on. For example, there's this kind of thunderstorm or whatever. And from time to time, they add new devices that are configured differently, so we have to handle the data from them, again, differently, right? And for all of those situations, they don't want to come to us developers and pay us heavy money to do development, right? So what do we do? Well, one thing to notice is that in this kind of system, there are probably many different user types, right? Each of them has different knowledge, different needs, and so on. So the first type of users that we have are kind of regular support team members. They only want to do some basic filtering that affect only a single event. They don't have the idea how to correlate events from different sources and so on. And to take some few automatic actions. For example, I want to defer this alarm. If the alarm comes from this device, I know it's broken, so let's just ignore it automatically. Right? So for them, we use something similar to that. This is some kind of a ready-to-use jQuery component. Actually, we use something different, but similar, right? So this is a simple widget that lets you kind of design in web application some basic rules how to process certain alarms. And for many users, this is enough. Then there are some kind of, I would say, half-power users, probably their management, who have the general idea how the system works. They know how to correlate different events. For example, when this router breaks, everything that's behind it also breaks. So if we have alarm for this piece, then we want to kind of ignore or just correlate the alarms for all the other stuff because it will break anyway. Right? So and they also want to detect time patterns. For example, if during 10 minutes one appliance will send 10 alarms, then probably we want to aggregate it in one. And for them, we let them use Drools. We'll talk about it just a little bit later. And they are the real power users, probably like 2 or 3 of them in the system, that want to, for example, be able to add new device types, right? These are the real power users, so for them, we let them use Groovy. And turns out, it kind of works, right? Groovy is kind of expressive enough and easy to deploy that few people in the system, because this is kind of technical system, few people can really grasp the idea and write Groovy codes. Of course, they don't have code completion, so it's not so easy for them to do it because many times they do it just kind of a notepad. So probably you'll need some kind of DSL for this to work, and you have to learn how to deploy this damn thing, how to test it. Probably you'd need some sandbox, so their rules, their scripts are separated from your core platform. But nevertheless, this approach worked pretty well for us, right? And the system was quite successful. So the lesson that I learned from this system is that not all your users are created equal, and sometimes some of them need a little bit more help and guidance, and some of them can stand on their own feet, and you just have to let them do their job. Right? Okay, now let's move to a little bit more enterprisey stuff. That is Drools. How many of you know about Drools? Oh, not so many of them. And the system is on the market for, I would say, like 10 or 12 years, since I remember. So there's certain appeal for systems like that with business people or analysts because of the acronym. This is BRMS. And it stands for business, so they know it's for them. That's rules. This is what they want to change. And then there's management, so everybody on the business side is kind of excited, and the system. So that's something that we throw at the IT department, and they'll run it, okay? So they are usually pretty excited by all those vendors, white sheets, and so on, and think they are able to use some kind of DSL to change the business rules without development. And then they'll end with something like that. Okay, this is how it usually ends. Of course, this is not readable by any business person. This has to be debugged by developers. So, yeah, it not always ends successfully. And we've been using Drools for more than 8 years, mostly for mobile operators. Some of our use cases were more successful, some not really. This was not a particularly successful one because we had to debug it and write it. But nevertheless, there are some quite successful examples. And one of them is the alarm management system I was talking about just a moment ago. So the idea is that we have all those events like alarm was generated by this or that appliance, and we have some kind of set of rules that are defined by, well, I would say analysts, and then using some additional knowledge, like for example, the inventory which describes which appliance does what, based on the current state of our knowledge about the alarms, it can generate some new kind of actionable insights, some new actions, right? And this enables them to, for example, correlate events coming from different appliances or different times, right? And the idea with Drools is pretty simple, right? Let's imagine this is kind of a different use case. It's more like next best action, for example. The customer comes to your point of sales and you want to check what is the best deal that you can offer them, right? So we have this rule. There's the when section. These are the conditions. For example, there's the status customer. It has status gold. And we correlate two facts, right? So he has the iPhone, right? And now we offer them some premium stuff. So this is kind of DSL-ish language that can be, with some effort, grasped by the analyst. And this, if you look at it, this is just plain Java code. So probably you'll need some DSL for that. But what is interesting in Drools is that in some configuration you can use it as kind of in functional way, right? You have some input data, you have more or less static rule set, and then it just outputs additional facts, right? So if you use it in a stateless way, just like kind of a function, it works pretty well, right? So from time to time the function changes. Think about it like serverless programming in server, right? When the function is delivered by the users, right? So when you keep it stateless, it works pretty well. But the real killer feature of Drools is this. This is called decision tables, and that's the feature that enables generation of rules from Excel sheets. It can even handle with nice colors, headers and descriptions, right? And okay, I see you're laughing, but this is true. This is true. I've seen places where business people really could produce like Excel with, I don't know, 1,000 rows and with condition for certain attributes. And here they just put some action like do, don't, or whatever, insert, delete. And we don't have to understand that. We just take this Excel sheet. You don't even have to export it to CSV. The Drools can handle them and deploy it and learn it. Okay, so here's some kind of code in Excel, but it can be hidden for business users. So you just say, don't you ever modify this cell, otherwise things will break, right? And as if you don't want to use proprietary software from Red Hat, that is Drools, there are also some kind of, say, standardization efforts led by people from BPMN and stuff like that. It was called DMN, and this is the aim to standardize some rule notation language. So if you are interested in that, you can look also at this. But, okay, so this is the way how it should work, but it's not always so nice. Because many kind of tech-savvy people, for example, analysts who have some developer background, tend to treat the rules as kind of bunch of if statements that are executed sequentially. And this is a natural way to think about it. But unfortunately, this whole Drools business is much more elaborate. On the hood, there's something called Rete algorithm that should make it fast for rules to execute when, for example, you have thousands of them. There are some use cases that need that. So under the hood, they work really in a really complex way, right? There's this Rete algorithm. You have to learn about forward and backward propagation. And if you just treat it as bunch of ifs, then you may end up with certain problems. For example, if your rules have some side effects, you cannot really control when the conditions are evaluated. If you try, you'll lose, right? So a friend of mine just gave me this picture that says, this is he and this is Tomek debugging your code, the code that you, Maciej, wrote some 2 years ago. And this is me. I'm trying to step aside, right? So you have to be careful about Drools. If you keep them simple and stateless, they'll give you a lot of power. And also, if you use these decision tables and Excel sheets, your users also will gonna love you. But if you try to think too much about how they execute, then the liquid abstractions can kill you and your DSL, right? So this was the first part of the enterprise stuff. Now we come to the ultimate enterprise. That is business process modeling notation. And again, this is kind of a holy grail of the hordes of vendors, business analysts, and so on. So again, the idea is this is your code, this is your business process. Your business analysts will use some easy to use web tool to generate this diagram. Then some analysts will fill some missing details. Just 1 or 2 developers will develop some integrations, and then it will be exported to this nicely looking and readable XML that, of course, every developer can debug, and everything will be deployed. Deployed in the process engine, and no developer is needed to handle all this stuff. You will be able to change it, monitor, and so on and so on. So there are quite a few commercial and open source frameworks that promise you to achieve that. And I would say my experience is a little bit different. I want to tell you about one project that we've been working on for, I would say, more than almost 9 years, right? And again, this is for mobile operators, which is one of our main points of interest. And this is kind of one of the critical business processes for mobile operators. That is number portation. So you have contract with one operator, and you want to change this operator and still have the same number so that your family and friends can call you. So there's a certain legal process that involves many parties, like central authorities who want to know who's the number, which operator owns the number, both the operators which have to agree at which time the number will switch ownership so that they can route this traffic, and also all this kind of provisioning, billing system, customer care, or whatever. So this is quite complex, critical process that should take less than a day, but if you are a problematic customer, for example, you don't pay invoices, then it can last for like weeks or even months. So as I've said, we started to implement that like more than 8 or 9 years ago with kind of predecessor of BPMN called Business Process Execution Language. I hope this technology lies in the grave for the rest of our days. And after a few years, we rewrote the stuff in BPMN, at least some of parts of that, with what was the most, I would say, advanced and popular engine there. It was called Activity. And for last 2 years, I would say, we are rewriting slowly everything into plain Java or Scala, right? So you may say, yeah, we ended up with a failure. It's not such a failure because the project itself was pretty successful, right? But our use of BPMN was not successful. But it was not only us, right? This is code from Twitter from Sam Newman. Probably you remember him from his microservices work. And he says, that probably this actually happens, that the promise that BPMN promises are not delivered, and we get the complexity without the benefit. And this is a question, and most people answered, we also see that. And I think that the problem is that these business process modeling tools focus on visualization. They tend to store the processes, the XMLs, in some kind of repository like database and stuff like that. And they want to enable the analyst to edit them with some kind of web designer. On the other hand, this is us, right? We don't want any clunky web designers. We want Git. We want our IntelliJ. We want to be able to extract functions or do whatever abstractions we want easily, right? And this is not really possible to extract a function from a process. At least it's not so. In theory, it's possible to extract sub-process, but it's not so easy. Not just Control-Shift-M or something like that, right? And we want to be able to use our continuous integration, deliver, and stuff like that. So if we are to modify the processes, we're probably unhappy because we cannot use our tools. And if we want to use our tools, we have to edit not in Visual Editor, but we have to edit these clunky XML files. This is not something that we want. But you may very well ask, okay, but it was supposed to be in that way that we don't modify process, right? The analysts modify process. But the thing is that in our case, and I would say probably in many cases, the problem is that the process didn't change that often, right? And when it changed, these were not necessarily business changes, like, for example, some thresholds, some conditions, and stuff like that. They were either some complex legal stuff that were enforced by the government and so on, or integrations with other systems, like this whole process integrated heavily with, I would say, half of systems at the mobile operators. So those systems change pretty rapidly. And from time to time, we had to change the integration. So the premise of BPMN is that when you have changed somewhere here in the core rules, then it's easy to change it and deploy it without touching the code that is developed. But our changes were more or less like this, right? We have to develop changes in this integration. That's the part that is done by developers anyway. And then we have to scratch a bit this process, right? Because the integrations changed. So we had to code anyway. So there's no use for business people or analysts to change it, right? And the other problem is that, this process is inherently stateful, right? It can last like half a day or a few months, right? And you know what? This handling state is hard, especially when you have some kind of sagas, compensating transactions, and so on. You don't expect your business people to understand what compensating transaction is, right? They probably want to think about stuff in some kind of different level of detail, right? So if the process is more or less stateless and not so critical, they will be probably okay. But handling timers and handling some exceptional conditions is not for them. This is for professionals like us, right? And even more difficult is the notion of versioning and handling changes in the process, right? Again, this is something that we have to think about, that when we want to deploy a new version of the process, then probably like 2,000 processes will still be running for like a week or a month or something like that. And we have to make a decision if we can just migrate them or let them run in the old way, and how to tackle that, especially when, for example, the integration changes and so on. So these are quite complex problems that you really want to be able to test properly before you deploy it into production. And this is another interesting example, because deployment in production is kind of tricky business when you have critical system. Again, this is quote for another client of ours. So he said, like, yeah, Maciej, I would be able to code that. That would just be just simple Java. I would be even able to package it and deploy it. But then my manager would ask, okay, but who is responsible for that? Who will be on pager duty, right? So that's why, even if we are able to code the stuff, we want you to do this, right? Because then we can outsource all this maintenance stuff. And if you think about it, this is kind of a real problem, because if we develop the code, then it can be, if we do it properly, and we do, it will be tested on many levels, right? First in our development environment with unit testing, continuous integration. Then probably we'll deploy it into some kind of test environment to check the integration parts, then user acceptance tests, and then production. If we let kind of more or less technical people or our client side do it, then probably they'll deploy it in test, if things are good, then to user acceptance test and in production. But if you let business people change the rules, then the best you can achieve is this, right? First deploy to user acceptance test, click some smoke test, and then deploy to production. And if you are not happy on the right track, then they will deploy it into production. So it's not so easy when you have kind of critical process, right? Think about it. On this x-axis, I don't know if you see it, there's a pace of change in your system, and on this y-axis is criticality. I mean, how important it is not to break things. So if you are here, not critical, changes slowly, who cares about that? If you are in fast changing system, which is really critical, then probably you're kind of a startup, so you probably have development teams. So this is not something that we are talking about currently. But those places are actually more interesting. So we were in this place when we had critical systems that didn't change that much. And probably if you are here, then you want the developers to do the job, right? It doesn't cost you that much, and you are more, I would say, if you have good developers, and you are more confident that it will work. But this place is actually a place where things like BPMN and other kind of zero-code systems will work. So the rules change pretty often. But if something breaks, it's not the end of the world, right? Right, so I think that BPMN can work in some more like workflow areas when you have simple processes, lots of human tasks that need manual approval, and if something goes wrong, you can compensate manually, right? This is kind of important, and they are not so focused on integration and orchestration just like we were. And if you are interested in that, if I can recommend some vendor, there's Camunda that doesn't sell you some kind of magic tool sets and acknowledge the fact that development is needed for BPMN systems. And today at Devoxx, there's a guy from Camunda speaking today at the end of the day. Sorry, I don't recall his name, but he's in the largest room as the last talk today. So if you're interested, this will be interesting. Okay? Okay, so what I've learned from our BPMN endeavors. So usually the coding, the creating the changes in business rules is not the problem. But running production, be able to test it somehow and be confident that you don't break things, this is the real problem. And if you have a lot of integrations and your processes are stateful, this becomes even greater problem, right? If you have integration and state, then probably you need this deployment thing. Right? So now let's recap a little bit what we've learned after so many years, right? So the first thing is that you should know your client. You should know him anyway, but this is very important. You have to know his level of competence. Can he just write visual diagrams? Can he use advanced Excel formulas, or can he even write SQL code? Right? So how technical they are? Do they know how really IT systems work? And then you have to know how fast the process that you want to develop, how fast it changes, right? Does it change every once in a while, like month, a quarter, or should it change almost every day, right? The next thing is that coding is not hard. It's the running maintenance as SLA that is hard for business people to grasp, and this is where we are probably needed to take responsibility, to be on pager duty. Yeah, I know it's not so pleasant, but we are the ones who should do it. And maybe if you want to let business users change the rules, maybe try to find the safer parts of the system that can't be easily broken, right? And important thing is to find a point when you will stop in your endeavor of letting business users change the rules. Some things are and will be better coded, right? All those exception handling, synchronizations, and so on. This is for us. So let's make it explicit and tell business users, okay, you can change this, but if you want to do this change, then, okay, you will have to go to the developers, ask them, wait a month before we develop and integrate it, and then it will work, right? So probably you will need something like Pareto principle, and in many cases I would think that 80% of the changes can be done by business users, but 20, you'd better do it yourself, right? And then this brings us to the, I would say, last part of this talk. That's my current project, and it's called Nussknacker, which is in kind of many ways based on the things that I've learned in the past projects, right? So this time we're in the domain of real-time stream processing. We have large streams of data, like probably thousands or tens of thousands events per second. We are again with mobile operators, so we have billing data, some kind of click stream, although it's not so big, and some signal data. Each time you use your phone, it communicates with base transmitter stations, and we gather the data and we want to process it. And what are the goals? What are our use cases? So the first one is marketing, right? If you go near point of sales, we want to check that you are near our point of sales and, for example, invite you to a coffee. Wouldn't you be happy to receive such SMS? I don't know. Me probably not, but still. But the other use case is more interesting. It's for fraud detection, right? There are lots of really interesting and innovative ways that people can make frauds in telco. It really amazes me how creative people can be when it comes to frauds, right? So many of the process looks more or less like this, right? We get an event that somebody called, some other number. We check if he is close to his credit limit, for example, if he's prepaid. If he's prepaid and he's close to his credit limit, we'll send him SMS, hey, just buy this additional, for example, data package, right? It will be cheap. And if not, well, for example, we may invite him to point of sales, right? So this looks pretty simple and easy to do with block diagrams. And to be able to handle such amount of traffic, we use Apache Flink. I think it was already mentioned here in this conference yesterday. So Flink is, if you know about Spark streaming, it's like Spark streaming, but far better. So it's, I would say, most advanced stream processing engine. And yeah, it has this nice DSL. This is Scala, but you can do it also in Java. That lets you define how this flow should work. Filtering, mapping, some reducing, and stuff like that. So for us, this is pretty readable. We can test it, deploy it, and so on. But for our analysts, not so. Probably with some effort, they would be able to read the Scala code, but to write it, to compile it, to deploy it, well, maybe not so much. So the project goes like this. We developed this proof of concept with Flink, hard-coded all the rules, and get really great performance results that really exceeded our expectations. And then our client said, okay, so now the rules are hard-coded, but what if we wanted to change it? And he said, okay, we'll prepare you some configuration files. You'll be able to change the thresholds, and it will be deployed automatically. Yeah, okay, but what if we would like to be able to change not only threshold, but, for example, add some other condition and so on? Okay, so we use this Scala language. It's not so complex. So we will let you write some nice small Scala expressions. You'll put it into a file, deploy it just for conditions. All the other stuff will be handled by us. It's easy. This Scala is not so difficult. You'll be able to grasp it, and it will be deployed. And yeah, probably we will be able to do it. But your commercial competitors have all these nice user interfaces that let us draw diagrams, like in Visio. Does Flink has this? Well, so of course we had to say, no, it doesn't have, but we can build it. We are talk, yeah. And we'll make it open source, so we'll have half of the money. Okay? And he said, okay. So we built this Nussknacker thing. I won't go into the details what it means. If you want, you can come to my quick talk later this morning. So we did this user interface for creating Flink flows, and we have this with assumptions that all the expressions, all the conditions should be accessible for kind of semi-technical people, not necessarily business ones, but the ones that know SQL. This should be a good baseline, and it should make it easy for them to do experiments, to do prototypes, and to make them confident enough to deploy them with our guidance. And we also assume that all the integration parts and more kind of heavy machinery will be still by us in normal code, right? So the idea is more or less like this. First, we code the integration parts. We put it in a nice fat jar that weighs God knows how many megabytes. We do some additional configuration of integration parts. For example, where is the Kafka that we use for message passing? Where is Flink, and so on and so forth? Where are the other system, for example, client profile? And then we let only users define the processes with some JSON, because it's kind of easier than XML. And we combined it and deployed it to our Flink cluster, again, using user interface. So how this JSON is generated by users? With something like this, right? So maybe it's not so advanced as Scratch, but still you can do quite nice processes with that. So you have events, some filters, some enrichments, and then some switch statements. You can put some variables and so on, right? And all these blocks are taken from some kind of a toolbox. When first we have some kind of generic statements of filtering and so on, but then we, developers, can code some additional integrations. For example, integration with additional systems like client profile. So we code the integration part that, for example, we want to invoke some REST service and so on. And then our analytic will only drag and drop the stuff and configure, for example, what is the idea of the customer that should be enriched, right? And then he'll configure all the business rules with expressions. And in fact, we didn't really use SQL. We used something like Spring Expression Language. Probably those of you who use Spring know that. And it's mostly used for configurations, but this was, for us, the easiest way to integrate into our Flink stuff. And it turned out, surprisingly, that it's accessible for our analysts to use. And what's even more interesting for me, it can be pretty performant. I mean, we invoke those Spring Expression Language stuff like probably 200,000 times per second, right? For a language that was created to be used for configuration, for me, it's kind of amazing. And it's simple enough for us to do some basic code completion, which is, again, very important for our business people or analysts. So again, with some React or generic JavaScript library, you can easily do stuff like that. And again, your business people are pretty happy because they don't have to remember which fields they have in the event. We can just do some basic completion. And if you ask how do we do more complex stuff like having windows, if analysis and stuff like that, how do they do it? Well, essentially they don't. Because we think that if you strive for completeness in your UI, for example, that you want to be able to let users do everything, then the complexity will rise exponentially. So what do? We code kind of more complex stuff, like more complex aggregations and so on. They are accessible for the users just as kind of blocks that they can drag and drop and configure, for example, the length of the window. But the general idea how this window works is coded by us, so it's safer, and they don't have to worry about that. And okay, so this is kind of how they design the process, but we want to reach some kind of feedback cycle. So first they figure out by running some SQL queries in their warehouse how this process should look like. Then they design it in our tool. Then we want them to be able to deploy it into some kind of user acceptance environment. Then on production, here they want to do some testing, both kind of sandbox testing and kind of pre-production testing, and then gather some data, right? So how do we do this? So there are two levels of testing. One is kind of, I would say, functional or sandbox testing. So this is how the system normally works. We take messages from Kafka, run it through Flink, probably enrich it with some kind of additional client profile, and send it other events, or, for example, block clients if he's fraudster. So for kind of sandbox testing, we take the data not from Kafka but from a file. We use still normal client data, and then we mock out the responses again so that the client can analyze them. So nice part about having this stream system in Kafka is that you can generate test data from your message broker, right? For example, you can take 10 last events, maybe pseudonymize it, and then let user use it for some kind of sandbox testing. And then he chooses the file and can analyze which event passed, which failed, were there any errors, and so on. And after he's kind of more confident, he can deploy it into our pre-production environment. Again, with stream processing, it's pretty easy because we can use the same database for our client profile as in production. Here we have kind of smaller cluster, so we can only deploy like 5 jobs instead of 15. But then we can replicate the production data, so he can see what is going on. Of course, we won't send real SMSs, but still after like 2 or 3 days, he can gather enough knowledge to be confident that when he moves to production cluster, it will work in the same way, because he was testing on real data, right? The outcomes were only recorded, but the data were real. So this kind of setup with stream processing is really easy to make it safe to do experimentations. And then for each process, some kind of auto dashboard is generated, so he can track the kind of his KPIs, like how many events pass, how many are, what is the latency, for example, and stuff like that. Are there any errors? How many events are filtered out at which stage, right? So you may very well ask, does this whole damn thing work on production? And well, for almost 2 years, yeah, it is. We deployed the system for one of the largest Polish telcos, and I've said it's for RTM fraud detection. So currently in peak, we process some with this tool like 100,000 events or 150. When you combine the output of all processes, we have like more than 50 of processes. Some of them are more technical, but most are for business use cases. And somebody managed even to come up with this kind of process. I don't really know how it works. Probably we would extract functions, do proper abstractions, and so on. But you have only such tool, then, yeah, this is something that you come up with. And as I've said, this is open source project. Of course, not the integration parts, but the core is open source project. It's kind of in development, but as I said, it's kind of ready to use for production, but don't expect too much documentations as for now. This is where you can find it. And if you want to see it in action, I'll be hosting a quick demo after lunch in this room at 12:50. And for now, I think it's all. If you have any questions, then I'll be here around, and thank you.